hello everyone. Today we are going to look over a very simple concept, which is basically the proving of irrationals. Now we are going to jump straight into this concept. It is a very simple concept, and for sure it is going to come for your unit tests, which are your periodics. It is going to come for your term 1. It's going to come in your pre-boards. And it's definitely going to come in your board exams. Okay, now we have to prove irrationals. Now from the term itself, proving irrationals, we have to prove that a specific number is irrational. Now in order to know what is an irrational, we know what is a rational number. You may come on, say it with me. A rational number is something which can be represented in the p by q form. In the p by q form, where p and q are integers. Simple. We learned this in 7th or 8th grade, I believe so. P and q are integers, and one more condition, q not equal to 0. Q not equal to 0. Anything divided by 0 would be undefined otherwise. So p and q are integers and q not equal to 0. Done. Thus this is a rational number. This is a rational number form. So any number 3, you can take 3 by 2, any number like that. Now what is an irrational number? Definitely an irrational number will be the opposite of a rational number. So an irrational number would be the opposite of this. It does not follow this basic p by q form where p and q are integers. Maybe q is 0. Maybe p and q are not integers. Maybe there's some other numbers. But irrationals and rationals together come under the real numbers. They together come under the real numbers. Okay. Now, since we have discussed rational numbers, we have discussed irrational numbers. Irrational numbers, some examples you have which they will ask you for proving is, some examples are, you would say, you have root 2, you have root 3, you have root 5, you have root of, let's say, 7, you have root 11, you have root 13. All of these numbers you have. And basically all of these numbers have the same proof, which we are going to look at now. Okay, let's go and see how the actual proof works of such irrational numbers. Now let's take an example, a very easy example. Let's take root 2. Now you may be asking, what is the point of proving this irrational since you already know it's irrational? Yes, that's a good question, but what to do? We have to prove it irrational. It is, CBSE, so we have to do this. Anyways, it's free marks, so it's a win-win situation. It's free marks, and it's simple and easy. Now root 2. So we know root 2 is what? Is a irrational number. So let's assume root 2 to be rational. Let's assume root 2 to be rational. Now what was the condition? Revise. What was the condition? Yes, it should be p by q form. So root 2 should be equal to p by q. Simple. But you have also write the condition in the bracket, otherwise you won't get the marks. P and q are integers, q not equal to 0. Also you have to add one more important thing, is p and q are coprime. P and q are coprime. This is a very important thing that you have to write. P and q are coprime. This is what you have to write for the first line. Okay, you have to start it like this. P and q are integers, q not equal to 0, p and q coprime. If p and q are coprime, that means their HCF is equal to 1. Simple. First step down. Now you take q to the other side. You take what? Q to the other side, you will get root 2 into q is equal to p. Simple. Now you have to do is what? You have to square it. Let's square on both sides. So if on squaring this, we will get root 2 whole square, which is 2, and 2q square is giving us p square. Now this is very important. This is the first conclusion which we have met. This is the first conclusion which we have reached. Now that 2 into q square is equal to p square. Now you can see that this q square, right, this q square, if I bring it to this side, it is divisible by p square. Now one thing you have to keep in mind is, in the textbook of NCERT, there's a very important formula which you have to know, or a very important property, that let's say if 2 and 4 are numbers, so obviously 2 divides 4, obviously, so 4 by 2, we can do 4 by 2, obviously. So 2 would also be divisible by 4 squared, 2 would also be divisible by 4 squared, 16 by 2, obviously. Same thing over here. So the square would also be divisible by the original number. See, look at this example. 2 divisible by 4, so 2 would also be divisible by 4 square. So 4 square can be divided by 2, and 4 can also be divided by 2. Simple. This is very simple over here. Now let's just erase all this again. Now we reach over here. Guys, I'm telling you, you have to memorize this. It comes by practice. This is how it goes. You have to write an important statement over here. It goes by the lines of this. This shows that p square is divisible by q square. Hence, sorry, I have made a mistake here. It's not this. It's not this. Now, as I discussed earlier again, that we took the example of 2 and 4, and it's very simple. So if you take p square is also divisible by q square, and it is also divisible by 2. Yeah, I can take 2 to this side, it would be divisible. I can take q square to this side, it would also be divisible. Yep. So this shows that p square is divisible by 2. Hence, p is also divisible by 2. As we discussed, that if we take 4 square and 4, and this is also divisible by 2, and this is also divisible by 2. Simple. That's what it means, the law. There's like a property in the textbook you have to know. They show that p square is divisible by 2, hence p is also divisible by 2. Conclusion done here. Now we are moving on to the next part of this proof, which is just the same thing. It is the absolutely same thing, but what we have to do now is not with p, we just have to go over to q. Now what we have to do is we have to take p is equal to 5r. Let's change the color. We have to write like this: for some integer r. Just random assumption. P is equal to 5. P is equal to 2r. My bad. P is equal to 2r. Random integer. Okay, for some integer, because it's root 2, so we took 2r. If it was root 5, you would have taken 5r, as I had earlier written. Okay, it's like that. You have to write it like that, whichever number you're taking over here. If it was root 13, you would have take 13r if it was root 13 to prove irrational. Now p is equal to 2r. We do the same thing. We square this. So we'll get p square is equal to 4r square. P square is equal to 4r square. Simple enough. Now what we had seen earlier, p square is equal to 2q square. So can we equate p square? Definitely we can equate p square. So p square was earlier what? 2q square. So you can just put 2q square is equal to 4r square, If you cut 2 on both sides, we'll get q square is equal to 2r square. Now again we have something similar. This is very important. You can box this up. Q square is equal to what? 2r square. So q would also be divisible by 2. Same thing that we have written here. Same thing. This shows that q square is divisible by 2. Hence q is also divisible by 2. Simple. Same thing we have done here. Okay, no need to worry. कुछ डरने की बात नहीं है. सेम चीज़ हम लोग कर रहे हैं. ठीक है. हमने क्या किया, हमने q p इक्वल 2r फॉर सम इंटीजर r लिया, स्क्वायर किया, ये लिया, ये सेम चीज़ करी हमने, and we wrote the same conclusion with the same things. Now what do we conclude now? Now let's check this is our full proof, by the way. Now if you look over here, we took p and q co-prime. Co-prime means that HCF should be equal to 1. Co-prime means that HCF should be equal to 1. But can you see something which is not corresponding to our assumption that we have taken here? Yes. P, see, we find over here on seeing P is also divisible by 2 and Q is also divisible by 2, but we took them as co-prime. So how is that possible? Exactly, that it is not possible. It is not possible for it to be like this. So as a final statement, what you need to write over here is that since P and Q are co-prime, as we have taken, HCF should be equal to 1, but they both are divisible by 2. Hence our assumption is incorrect. Simple. Hence our assumption is incorrect. Hence our assumption is incorrect. So therefore, since our assumption is incorrect, we have to put a very straightforward word here. If you don't add this word, you might not get the mark. Therefore, a contradiction. A contradiction has arisen or arisen. What's a contradiction? Like, contradiction is basically, let's say I told you Rahul has a red jacket, but someone else told you that Rahul has a blue jacket. Now these two statements are regarding one thing, but they're contradicting each other. They're opposites. Same thing. What we assumed is contradictory to what we have concluded with our proof. Yes, so a contradiction has arisen. Therefore our assumption is incorrect, we wrote. Hence, therefore again, root of 2 is irrational. That is our proof done. Let's revise. Okay, let's revise. Don't worry, be happy. Okay, 10th grade's a calm year. It's gonna be the most enjoyable perhaps year, maybe. So what we discussed earlier was the proving of irrationals. We know rational number p by q form, 2, 3 are irrationals. Now our main proof starts over here. Let root 2 be rational. Assume root 2 equal to p by q. Okay, take it to the other side, you are squaring, and you have to write this condition: HCF is equal to 1. They're co-prime. Very important, very important, very important. Okay, very, very important. Now 2q square p square, now we have gotten it equal. This shows that p square is divisible by 2, hence p is also divisible by 2. Remember the law, remember the law. What? That if the square is divisible by something, the normal number is also divisible by the same thing. Now we've taken p is equal to 2r for some integer r. Again we do the squaring, again we do the same thing. You see this p square and this p square equal. Now you what? Combine, or you equate it. This we get the same thing. We get 2 over here. Now this shows that q square is divisible by 2, hence q is also divisible by 2. Same thing over here. Now the final conclusion what we have reached to, since p and q are co-prime, as our assumption, HCF should be 1, but they both are divisible by 2. Hence our assumption is incorrect. This therefore a contradiction has arisen. Therefore root 2 is irrational. This can directly come for your exam for either 2 marks, 3 marks, or if you're very, very lucky, you're feeling it, you'll get it for 5 marks, because it does come for 5 marks in the PYQs. You will see it. Thank you so much for watching. I hope you really understood what I tried to explain today. More such short concept type videos are coming soon, and till then, just grind and take it easy. Grind, but take it easy. But you still have to grind. See you.